Alright, we're going to talk about translations and rotations. Translation is just when you move a figure up, down, left, right, you just kind of slide it to a new position. It doesn't flip or rotate, so what's on top stays on top, what's on the bottom stays on the bottom, and so forth. You just slide it to a new spot, up, down, left, or right. Alright, so in example 1 it says translate the figure left 6 and up 8 and give the coordinates of the new points. So for each one of these points, individually I just count left 6, up 8 and find the new point. So from A, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Here is A prime. I went left 6, up 8. And so those coordinates now, when I count the coordinates, I always start counting from the origin. 1, 2, 3, 4. I went left 4, which is a negative 4. 1, 2, 3, 4, 5. So negative 4, 5 are the coordinates of A prime. And I just do this exact same process, repeat it over and over again for each point. So with B, left 6, up 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So there's B prime, and let's check the coordinates from the origin. 1, 2, 3, 4. Didn't go up or down at all, so that's negative 4, 0. Okay, I'm going to do C. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And here's C prime, and that's at the coordinate 2, 0. I went to the right, so this time the x value is positive. Okay, D, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. There's D prime. So from the origin, right 2, and then up 1, 2, 3, 4, 5. 2, 5. And the last one, point E, left 6, 1, 2, 3, 4, 5, 6, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And here's E prime, and from the origin, left 1, up 3, at the coordinates negative 1, 3. And then I can just draw those lines to line segments to connect these points and create that same similar figure, actually congruent figure. We didn't change the size or shape or anything, we just moved it to a new location. And there's our translation, left 6, up 8. Alright, on example 2, we want to describe each translation. So this time the translation's already been done, and we're just going to say what happened. Now there are formal ways to write this. We're just going to say how far up and down or left and right it went. Now, the first one we want to do is from A to B. So we want to go from this figure to this figure. Now what is important is understanding in a translation, again, whatever starts in the top left-hand corner is going to end in the top left-hand corner. So I don't want to count from here to here, because that would be the bottom right-hand corner and the top left-hand corner. Those are not corresponding parts. So I can start from any of these 4 points that I want, and I just need to count to a corresponding part. So if I start with the bottom right-hand corner, I need to go to the bottom right-hand corner. So let's just do our left and right first. So let's see how far I would have to go to get from here to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. And then I'm going to have to go down 1, 2, 3, 4, 5. So I went right 10 and down 5. And that should work for every single point from A going to its corresponding part of B. So like if I started with the top right hand corner and I went to the top right hand corner, I should again go right 10 and down 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Alright, let's check on the translation from B to D. So I'm going to use bottom left hand corner and go to the bottom left hand corner. So I'm going to go right 2, down 1, 2, 3, 4, 5, 6. Right 2, down 6. Again, it doesn't matter which point you use, just make sure you're going to its corresponding point. Okay, and the last one, translation from C, or from D to C. So I'm going to start with D. I'm going to take the top left-hand corner, go to the top left-hand corner of C. So I'm going to go left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Down 1. Went left 12 and down 1. And there's our translations. Alright, three-dimensional figures can be made using translations. Let's first start with plotting these points. So I got the point A at -2, -2. So there's A. B is at -2, 1. So there's B. C is at the point 1, 1. There's C. And then D is at the point 1, -2. Alright, so we've plotted those points. It says connect the points in order. So A, B, C, D, and then back to A. So what we have is a triangle. Now that's just two-dimensional. Now it says translate the figure 2 units right and 1 unit up. So I'm going to take each one of these points and go 2 to the right, 1 unit up, get a new point. So for A, 2 to the right, 1 unit up, here's A prime. D, 2 units to the right, 1 unit up, here's D prime. C, 2 to the right, 1 up, there's C prime. And then B, 2 to the right, 1 up, and here's B prime. Alright, it says draw segments A to A prime, line segment A prime, line segment B, B prime, line segment C, C prime, and line segment D, D prime. And what I forgot to do earlier is connect the 4 that we made just a moment ago, just like we had on the original. And you should notice that we have now a cube, or at the very least a rectangular prism. If you're not 100% sure about these side faces and how big they are, at the very least you have a square or rectangular prism. But it looks like it's probably a cube. Alright, so that was translations. Let's look at rotations. Alright, we got 2 types of rotations. If it's going this way, that type of rotation is clockwise. And if a rotation is going this way, that is called counterclockwise. So we can rotate either direction. Okay. In one full rotation, there are 360 degrees. So 90 degrees would be 1/4 of a rotation. 90 degrees is 1/4 of a rotation. It's 1/4 of 360. Now, when we rotate 90 degrees clockwise, here's a pattern for the coordinates. It's going to switch the x and y, and it's going to make the x, what was the x, negative. Okay, here's the rule for going 180 degrees, and 180 degrees is half of a rotation. It's half of 360. And here's the rule for that one. Okay, 270 degrees is 3/4 of a turn. And here's the rule for doing that. And then 360 degrees is 1 full rotation, so you end up right back where you started from. So it's just x and y like normal. Now that's all going clockwise. If we go counterclockwise, the rules are a little different. So 90 degrees counterclockwise, we end up here. 180 degrees counterclockwise. Now think, because 180 degrees is half of a rotation, no matter which way you go, if you go halfway around, you're going to end up at the same place. So the rule for going 180 degrees clockwise and 180 degrees counterclockwise is actually the same. And then if you go 3/4 of a rotation, 270 degrees counterclockwise, you end up with this rule. And then a full rotation again will put you back where you started from. Now also, the 90s and the 270s, notice these are the same and these are the same. because when you do a rotation, going 270 degrees this direction is the same as going 90 degrees this direction. They both put you at the same place. Alright, so let's see if we can describe these rotations just looking at them. And then in a moment we'll apply what we just wrote down for example 5. Describe each rotation. So there's actually two different ways we could describe this. If it's going clockwise, it went 90 degrees clockwise. That's 1/4 of a turn. So you could say that rotated 90 degrees clockwise. And 90 degrees clockwise would be the same as 270 degrees counterclockwise. So either one of those descriptions would work. Okay. P, in this case, was rotated 90 degrees counterclockwise. And 90 degrees counterclockwise is the same as 270 degrees clockwise. And then C was rotated halfway around. This has been rotated halfway around, and halfway around is 180 degrees. And I don't really need to write clockwise or counterclockwise because it could be either one. It's going to be the same. Alright, let's see if we can do example 5. We're going to actually do the rotation. It says draw the resulting triangles when the triangle is rotated 90 degrees, 180 degrees, and 270 degrees clockwise about the origin. Okay, and so it's also important that we're rotating around the origin. Alright, let's write down our original coordinates here. The coordinates of A, 1, 2, 3, 4, -4, 2. The coordinates of B, 1, 2, 3, 4, 5, 6, 7, -7. 2, 3, 4, 5, 6, 7. -7, +7. The coordinates of C, -1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. -3, 9. Alright, these are our original coordinates that we're starting with. Now, I can use these rules to know exactly where I'm going to be when I rotate each one of these places. So remember, when we rotate 90 degrees, we're supposed to end up with y, -x. Y, oops, I said y and I wrote x. Y, -x. That's where we're supposed to end up after a 90-degree clockwise rotation. So if I'm doing this for A, the y was 2, x was -4, and I want a -x. So if I take a -4 and put a negative in front of it, two negatives make it positive. So after a 90-degree rotation, that A value, that A prime now, is going to be at the point 2, 4. Here's A prime. Okay, so for B prime, the y value from B was 7. And then I want -x. The x value is a -7, so if I put another negative on that, it's going to make that a +7. So the B prime is going to be at the point 7, 7. And then for C prime, the y value from C was 9. And then the x value was -3. Again, we're going to put another negative in front of that, so that's going to make that a +3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And here's C prime. This was B prime. So now I can draw this triangle. And that's where it should be after a 90-degree rotation. Just think about this being a pinwheel, and it's just spinning around there, 90 degrees rotation. Alright, let's try it with 180 degrees. Now at 180 degrees, the rule is -x, -y. So notice the rule just has us leaving the x and y right where they are and putting negatives on them. We're changing the positive or negative. So if x was at negative 4, 2, and I'm just changing the positive and negative on both of those, this would now be a positive 4, and this would now be a negative 2. So I'm going to plot the point 4, negative 2. Okay, for b prime, again, we're just changing the positive or negative, so this is now going to be a positive 7, and this one will be a negative 7. And the last one for this, we had negative 3, 9. We're changing the positive or negative on both, so now that's a positive 3, and that's a negative 9. So we got the point 1, 2, 3, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. And here is C prime. And so that's what we would get after a 180-degree rotation. We rotated this thing around halfway around the circle. And then we have one more to do, and that's the 270-degree rule. Negative y, x. Okay, so now we want to take the original y value but change the positive or negative on it and put it in the x place. So for a prime, the y value from a was 2. I want negative y, so that would be negative 2. And then the x value was a negative 4. So a prime should be at negative 2, negative 4. So there's a prime. Okay, for b prime, the y value on b was 7. I want a negative y, so I want a negative 7 here. And then I want the x value to go here, and the x value is negative 7. So I should have a point at negative 7, negative 7. And the last one is C prime. And the y value was 9 on C. I want a negative y, so I want a negative 9. And then we want the x value to go next, and the x value was negative 3. So I want to point at negative 9, negative 3. And there's our figure after it's been rotated 270 degrees clockwise about the origin, 3/4 of the way around. So hopefully you kind of see that pinwheel action happening as these are just rotated around the origin. Alright, now I showed you how to get that using the rules that we already wrote down. I'm going to give you one other way to do the exact same thing, and that's by just rotating it physically like I was just doing. 360 degrees is a full rotation. 90 degrees is 1/4 of a rotation. Well, this just happens to be broken up in 2/4 by these quadrants. The x and y axis break it up into quadrants 1, 2, 3, and 4. And each one of these x and y axes form a 90-degree angle. So when we're rotating, basically this quadrant moves to here on 90 degrees. It moves here 180 degrees. 270 is 3 of those quadrants around, and then 360 puts it back at the beginning. So one thing I can do is just, if I want to rotate this 90 degrees, rotate it 1/4 of the way around. Rotate it to where it's at this quadrant. Check the points. So A is now at 2, 4. Notice when we used our rule earlier, we figured out A prime was going to be at 2, 4. Get it rotated 90 degrees. B would be at the point 7, 7. And that's where we figured out B prime was going to be. Rotate it 90 degrees. Where is C? 9, 3, which is what we found out. So then I would just put my paper back normal, and I would plot those points now that I've written them down. I'd plot 2, 4, 7, 7, and 9, 3. If it's rotating 180 degrees, I know I'm going to turn it 1, 2. I'm going to turn it to where this is now down here. So I just rotate it like this. 180 degrees. My paper should now be upside down because I've gone halfway around 180 degrees. And I would just figure out what are the coordinates now based on the way this is positioned. A is at 1, 2, 3, 4, negative 2, which is what we got. B is at 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4, 5, 6, 7. So 7, negative 7, which is what we got for B prime. And then C, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, negative 9. So I would write down those coordinates, I would turn my paper back the normal direction, and then I would plot those points. 4, negative 2, 7, negative 7, and 3, negative 9. So this is another way you can do it. Just rotate your paper the number of degrees that you need to rotate it, write down what those coordinates need to be, and then turn your paper back the normal direction and plot those points.